Hello, streaming again, live. How do? Back on this circuit board, this Epoch, Maygay Epoch PSU Mark 1. Just make sure I'm streaming okay. So I've had a bit of a tidy up, sort of, with the cables. Bit of a reroute. I've got rid of the fluke meter out of the way. I'm back on. Changed the display slightly. Back on this one now. I'll go on that one. I've got the scope on the go as well, and power supply. Okay. Let's just make sure I'm streaming. Yeah, looks like we're streaming. Okay, let's go into it. Let's change the quality down. Yeah, looks like we're streaming. Just set the quality low and turn the mic off, just so I can make sure I'm streaming. We don't need that in a full window. Size the window smaller. Okay. Right. Okay, give that a chance to catch up. Right, gonna do some more tests. I haven't done any more reverse engineering of the circuit board, but what I want to do now is measure the AC out of the transformer, out of the secondary side of the transformer. Now I've got, let's turn that on. Yeah, now I've got this drawing. Back to this again. Yeah, so you've got this bit of the drawing here. This is the connector that's there. Oh, you can't see it. There you go. That connector there. So that represents, it's around that way. I don't know if I can get that on there. Yeah, that represents that. Basically. I don't know if I can put it there. Doesn't like the light, does it? Anyway, I'll leave that off screen for a bit. Okay, so I'm going to put the power back on this again, and now knowing that some of these, hang on, is there anywhere we can put that? Let's just bring that down a bit. Yeah, we know now that the light's not very good, is it? I don't know if we could do it that way. Yeah, that's probably better, isn't it? Well, fall off the table. Right. Okay. Not good. Anyway. Right, I don't matter as long as I can see it. Right, so basically some of these wires here, they're not connected. They're not commoned up on here or on the circuit board exactly underneath. They're going off, the traces are going off around the board, and they're being jointed around the board. So it's not easy to find out without a meter which ones are jointed. Anyway, so what I'm going to do now is I should be able to determine. See, what I'm going to do now is fill out this bit here. Yeah, will that go there? Yeah. Let's get the soldering out of the way a minute. Yeah. So There you go. Right. So I've got to find out which terminals are the power. I know that's ground, 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 ground. That's a voltage. These two will be a voltage, and that one, and these are the mains. So what I'm going to do now, just to see if I've got any AC, just to make sure one of my windings isn't down. Right, so plugging the power supply back in. That's the mains in, and we're using the meter at the top, unit T, UT801. We're using this one here. Just going to use that one. I've got a Handtech USB one which we can capture the screen on in OBS, but for some reason every time I touch the probe on anything to do with mains or power, it disconnects the USB. Or it resets it. Basically it's like unplugging it and plugging it back in again, so I'm not sure. I bought that. The only reason I bought it was to be able to put it on the screen, but then I'll have to check the isolation on that. For some reason it's not liking. I wonder if I can give it a separate supply, maybe. Doesn't really like the probes. You touch the probes onto some steel or some power around the board, it disconnects. So it's a bit of a weird thing. Right, I'm going to switch it on now. There we go. Right, we've got mains on. I need to get a minus voltage. No, not on this occasion. I don't need a minus voltage. I need the other. I need to find a common. So that's basically upside down. So let's turn that around that way. I'll leave it off the screen. Alright, so according to that, the second and third pin from the bottom here should be common. So let me see if I can get a supply down it. The only thing I've got to be wary of is the red and the black, which is live power. Don't want to touch that. Right, so what's an easy one to get to? This one here, apparently. I don't know if I can, let me just see. Can that be volts? We want AC. Volts AC. Let's go on to AC. 200 volts. 200 volts AC. So why is it reading 6 volts? That's stupid, isn't it? AC range. We're reading 10 volts, and I've got the probes here. There's the probes. They're not even touching anything. Oh, that's a weird one, isn't it? It's just picking up floating. How can it be 8 volts floating? That's silly. Not a decent meter. Anyway, let's get some AC. Now they're jointed up. I think they're commoned up as well. Let's just ignore that for a minute then. So those two greys are the other sides of the transformer. Right, let me see if I can get a voltage out of this. Right, well, we got 18 volts on there. Let's try going up a bit. What we got? 10 volts. Well, we've got 11 volts without the probe. I don't get that. What are we on here? Volts AC. 200 volts. Why are the meters rubbish? I'm tempted to get the old Evo out. Have I really got to get the fluke back out? Oh, what's going on there? How can I be getting... Touch the probes, you get 0 volts. Let them float, you get 9 volts. Move the probes around, you're getting all sorts of weird. How can you trust such a thing? Right. Never really tried that on AC yet, and I don't suppose many people do. Not initially, anyway. Right, let's get back to it. So, third one in is purple. So those purples and the greys, basically the 2 purples, the 2 greys are common, so they'll be like a centre tap. So let's just see. I need a minus figure here somewhere. 32 volts. $12 volts. 11 volts. That's crazy. I can't get the right voltage with this thing. Right, let's abandon that one then. Stick that back on DC. I don't think that's any good on AC. It's a brand new unit. Last year, couple of years. Never really used it yet. Anyway, I wonder if it's been affected by this switch mode supply next to it. Let's just put it back on a minute. I got 5 volts I'm reading. Put my hands on it. Goes up to 6 volts. Turn this off. Oh. And floating probes. I've never seen anything like that. Mind you, these aren't the right probes for it. I wonder if I got dodgy probe. I don't think so. This is rubbish, isn't it? This is rubbish. Oh well. Leave that where it is. Let's get the other one back. This is why you buy fluke. That's exactly why you buy fluke. Don't buy anything but fluke. Even got a light on it. Right, let's put it. Don't even have to select AC, it does it automatic. It's important to get your lab sorted out. And these rubbery leads, look at them. Get out of the way. Right, so I've got our meter. I'm gonna try again. Oh, I got these horrible probes. These probes that come with this, hang on. They're not the kind of probes you can... Let's swap them. You got horrible probes that you can't push down the side of a plug. They're the same. Right, it's going to be awkward anyway. So it ain't one thing, it's another. Right, I better put the stream up. Better put the stream up because in case there's anybody talking. Oh well, okay, there's nobody watching. Hello all. That'll do. Right, get back to it. Let's see if we can get down there and get a meter on there. No, can't get down it. That's it. So let's change these probes. Or at least one of them. Right, we've got to borrow a probe off the meter that's no good. AC range is weird. Right, here we go again. So we've got that down there, and we're going to go into here. 18, you can't even see now. $18 AC on that one. How do they do the minus? It's not going to show you a minus supply, is it? It's AC. The only way to detect that is the phase. So you can't actually tell which is the plus and minus. There is no plus and minus. It's 180 degrees out of phase with the other one. Or is it? Right, it's worth that. Right, where are we? So that first one is definitely a power, supposed to be a power supply. We'll have to change the other probe as well. These fluke probes, they're designed to be extra safe, but you can't reach anything with them. All the plastic surrounding them and the probes at weird angles. Right, we've got some cheap and nasty probes now, but at least we can touch things with them. Alright, what we got there? You can't see. My hand's over it. That's stupid, isn't it? Right, what we got? 32 volts there. So that's 32 volts AC. So I'll just write that down. What do I do with the pen? Oh my god. Disaster, isn't it? Right. So the first one is 32 volts. 32 volts AC. Let's find another one. The other one up here is 18.6 volts. So 18.6 volts. Couldn't find this written down anywhere, by the way. Could do with a. I'll tell you what I could do with an adjustable table to lower the workpiece down flush with the tabletop. That'll be good. So this one's 18.6 volts AC. Okay. Let's see what else we got. We've got another 2 voltages in between. On not the greys, on this purple and the yellow. What we got? 18.6. Now I've got to say that would be one of the 12 volts to the minus. So that's 18.6 as well. Okay, that makes sense. So we got 18.6 volts AC. So that looks like it's pretty much our split rail, dual rails, not rail is it? Dual rail power supply. So in that case, if I measure between the two 18s, if I measure between the two 18s, I should get 18.6. I should be getting 37.2 volts. Let's give that a go. 37.2 volts I think we're going to get. So here we go. 37.2 volts. Do we get it? 13 volts. Am I on the right one? So it's that one, missed 2, and then that one. Oh, look at that. 37.23 volts. So I now know that is my plus and minus 12 volt. Well, it was what becomes my plus and minus 12 volt. So that's identified. That's brilliant. So next one is the 5 volt. We've got to have a lower voltage for the 5 volt. Unless I wouldn't have thought it uses the same windings as the plus and minus 12 volt. Right, so the next one will be this yellow wire. Let's see what we got there. $32 volts again. 32 volts. Why have we got 32 volts? It's a bit high, isn't it? So that's 32 volts. We've got 18 there. 32 volts there. Okay. So let's write that one down. We've got 32 volts AC. And that's it. So I've got two 32 volts. So if I measure between the two 32 volts, should get 64 point something volts, if that's a split rail supply as well, or plus and minus. Let's do that then. So let's go between that one there and the first one. Will that give me 60 odd volts? Let's see. Oh yeah, there we go, 64 volts. We've got it. So basically what we've got is we've got it's been wired up as two 18.6 volts, 180 degrees out of phase with each other. Would they be out of phase? Yeah, they'd have to be. Joined to the middle, so split rail. Or who can they be out of phase? It's off the same supply. Maybe not. Maybe just got split supply. So we've got 36 volts centre tapped. So it's a 36 volt winding, but centre tapped to give you a split rail supply. And we've also got a 64 volt supply that's split rail centre tapped. So we've basically got we can have yeah, you can get all sorts from that. Depends on where you take your sample thing from, centre point. So we can have 64 volt, we can have 32 volt, two lots of 32 or 164. We can have two lots of 18 volt or 32 volt. 34 volts, sorry, 32. Yes. 36. Yeah, 36 volts or two 18 volts. Okay. So if they want to do a plus and minus 12 volts, the best way they could do it was probably from probably from the 18.6 volts. Although they could go the other way. Don't really know what they're doing with it. Now what we can do is measure the diode before when it comes into one of these diodes. So if I put into common down here, stick that into common, and one of these diodes, what we got, 32 volts coming in there. Oh, shorted it out. Don't want to do that. Did you hear that then? I hate these probes, they slip. That's embarrassing. Yeah, nearly shorted it out. The power supply started humming then with a lot of draw. Luckily it was quick. No fuse blew, so gotta be careful with these probes. So have we lost it? Did we blow a fuse? No. 41 volts. We're up to 41 now. Wonder why it's gone up a bit. Must have give it a kick in the butt and woke it up. Yeah. Right, gotta be careful. 18 volts. 5.3. That's DC. AC. 41 volts. It's gone up a bit. Wherever I've done it seems to have woke it up a bit. Or shorted something out, but I doubt it. Probably did it good. Right, let's just measure the voltage down here. What we got? Can't see my hands in the way. Still minus all over the place, that is. Should be minus 12 volts there. So what do we do next? Let's have a think. So what about if we put some load, a bulb, 12 volt bulb on the minus and plus 12 volts, so we can get it to light up. I remember having a dummy load bulb set up somewhere. Let's see if I can find it quickly. What have I got that's supply 12 volts. Not a lot. Right. It's not going to be easy to find. Well, I'm back again, but it's not going to be easy to find. You got a lot of trays. I don't think you can see my trays. No, you can't see that. Right, I need a dummy load. Something 12 volt. What's better than a car bulb? Not much. Right, so we're not getting very far today. Again. So, what can I do? Let's do a few more tests. A few more measurements, see if we've lost anything. So we've got 41 volts there. Why have we got 41 volts AC? Yeah. So 36 volts. It's gone up to 39 volts. 38 volts. 38 volts. 18 volts. 18 volts. 39 volts. 38 volts. It's gone up a couple of volts just because I shorted it out. That's weird. Nothing's warm. No. That's strange, isn't it? Anyway. Right, what I wanted to measure was the AC windings. I measured them and they're definitely giving out. They're giving out the right voltages. But they're not being switched correctly. What can I do as the next test? Right, I'll switch it off a minute and have a think about that. Ideally, I'd find a dummy load bulb. Just trying to think. It's been ages since I put them things away in the drawers. Right. What we're looking at, 31 minutes. 31 minutes. There's a lot to be said for having some bulbs lying around. Incandescent bulbs. I could put a resistor across it. Yeah, I could warm a resistor up. Yeah, I could put a resistor across it. I know I've got some resistors. Let's have a look here in this lot of stuff I got here. Got a lot of stuff just hanging around here. Oh, there you go. I've got a few high-powered resistors. Yeah, maybe we can put some of them on. Right, so we found, there you are. Can't see that, can you? There you go. What we got? Tyco 12 ohm. We've got 12 ohm resistor. What happens if I put that across something? It's gonna be funny. 12 ohms. Yeah, 12 ohms. But I got 3 of them. 3 12 ohms. So if I make some, solder some leads to these, put it across the AC, for instance, what will that do? Draw some current, get warm. How warm will it get? I should be able to work that out. How many watts will it dissipate? $12 ohm resistor. We'll never know unless we try it. Let's stick this soldering iron on. Of course, my sponge is dry again. When they're going to invent a sponge that keeps itself wet? Unless they already have done. Well, I'm just wetting my sponge now. You can't see it, it's just out of shot. Right, it's wet. Why would you want to invent something that wets a sponge when you can just wet it that quickly yourself? Right, just eating the iron up. Showing me 400 degrees C, but well, that got up to heat quick, didn't it? Don't think it shows you actual temperature on that one. So if I wire, I ideally need some probe leads. Yeah, so I need some probes with pointers on the end. Ideally, let's see what I've got. Do you like my Commodore shirt, by the way? It's probably not an official one. Right, let's go. What we got here? We've got that. That's probe. Stick a crock on the end of that. The next problem is going to be finding some cable. I've got no cable. Why don't I just order some rolls of cable off eBay or somewhere? Some red and black thin stuff. Nothing worse than having to make stuff. I've got lots of probes. I've got lots of probes. I've surely got lots of probes. I've got lots of wire. I'll never use them all. Right, I've got these. I've got this weird thing here. Look at this, look. Look at these. Got red and black. Loads of these. Can these be used? I don't know. Let's have a look. So pull that one off there. So I've got a little lead with two ends. Not really. They're too good to break, aren't they? It's the trouble, you got lots of leads, but they're no use really, unless you're going to destroy them. What did I do last time? I found wire last time, didn't I? I found wire to do that last time. I'm here. Oh yeah, cut some off there. Oh well, I'll cut some more of that then. Poor radio's suffering again. I'll cut some off the radio lead. There it is. Never mind. Needs must. So it's got a solder joint on anyway, so. Right, so I'm going to strip these wires down. It's getting very hot in here. The iron's up to heat now, so let's solder some of these on these dummy loads. We want some dummy loads. Okay, let's do the first one. You can't see that. There we go. Let's get some solder, let's tin it. Reel the solder out. That's not a good idea near the mains, is it? Tell you what, I'm going to unplug the mains, just to be safe. My mama said it's better to be safe than to be sorry. Saw that in a film once. Nothing original, it's all out of films. Right, let's get this soldered in here. Easier said than done when it's our great big heat sink. Yeah, that'll do it. Right, tin the wire. Okay. Throw that on there. Oops, need some helping hands. Why don't I use the helping hands? I got some helping hands. Oh, shaking. I can't do it. Let's do the helping hands. No matter how much stuff you got, you've still got to struggle. There's no real estate. I've got the bench, but there's just no real estate. I don't know how these youngsters do electronics anymore, because it's probably infuriating. It's the trouble that they got their phones and everything's done with apps and phones, and the real world there's a joint. That's it, that's pretty good. Right, let's do the other side. Yeah, the real world, you have to fiddle around with fiddly stuff. Awkward stuff. You have to make a saint swear. Anyway. Let's make a few of these dummy loads. I'll just make one for now. I'll try it on one in it. Let's get some piece of wire. Oh dear. 20 to 9. Sunday, 20 to 9. Back to work tomorrow. Just gonna sell. The solder's going crazy. You can't see that. Bloody hell. Why can't I make solders just stay still? Right, yeah. Let's solder this. It's very, you have to be a contortionist to get working in reverse handed. Struggling. It's only supposed to be an LB. Not supposed to struggle. Anyway, we've got a soldered joint. Now if you wanted to, you could heat shrink that up and that, but I'm not that bothered. Right, so what's going to happen when I plug this into something, huh? What is going to happen? Shouldn't do a lot. It's going to get hot. Very hot, maybe. And it might start buzzing. But I could either put it on the AC or put it on the DC. Yeah, I'll try it on the DC. Minus 12 volts. I've got to tin these wires now to make them rigid. I did something silly the other day. I deleted loads of subscribers off YouTube. Well, what I was subscribed to. I was getting confused. There was too much stuff being fired at me. So I got rid of them all, but now I've got nothing to watch. It's mad, isn't it? Right, so we're about ready. Let's get rid of that helping hands. Coil this solder back in before I get electrocuted with it. I don't want solder drop lying around the place when you got mains going on, especially. Right, so I think I'll do the DC side, see if the voltage comes up, just to see if it needs a load for it to come up. Let's get rid of these out of the way. Right, so I need to connect, so I could do crocodile clips now. Crocodile clips, so I've got some crocodile clips. Let's get some crocodile clips. What do I do with them? See if I got any crocodile clips. No, not there. Loads of banana plugs. Loads of banana plugs, but no crocodile clips. I'm sure I've bought crocodile clips before. Let's go and find some crocodile clips. Let's go and get some. I've always got crocodile clips somewhere. Right, I'm over here. I've got 1,000 of these drawers, so I don't know which one's got the crocodile clips. There's no crocodile clips in that one. Oh, that was a bit of luck. That was a nice bit of luck. Look at that. Full of crocodile clips. It's very good. Right, so I've got these screw-on ones, don't want them. These non-protected ones, they're not good. Ah, here we go. We've got some nice little rubber insulated ones here. Lovely stuff. And that's why you buy a few spares. So when you need to do something, you've got some. So to get that shroud off, so you can solder it, fasten it onto something and pull the shroud off. Right, that's going to be the black. Put the black over the shroud. Don't need that much solder now. Right, here we go. Oh, helping hands back again. So what happens when you put your helping hands away too quickly. Okay. Solder line back out, solder it back out. Tin it. That'll do. Right, solder on. I'm not gonna fold it over. I'm not gonna crimp it on because it's only temporary. Yeah, I'm not gonna fold the ends over. It's temporary, so I want to reuse this another day. Okay, let's get that back over there. Fiddly job again, another fiddly job. Fiddly bastard. Need something wider. Shit. That's it. Go on. Right, so we've got a nice end on now that's not going to short out. Got to do the same again now. One more. This is painful. Never mind. Fiddly jobs, eh? enough to make you shout. Right, can you even see that? Just about. Don't matter, it's only me tinning crocodile clip. Been tinning a crocodile clip. I was thinking all these YouTube videos, everyone's uploading them. At some point, what the hell do they do with all these videos? YouTube, where do they store them all? Where do they put them? There's loads of them. Imagine they're never gonna be gone. They're gonna be around forever. This is hot. I'm trying to do this hot. Look, see, that's painful. Yeah, so they must have some hell of a service to save all those YouTube videos. Right, so we've now got a lead with 2 ends on. So get rid of that. I can turn off the solder on a minute. Wind in the solder so we don't get electrocuted by bits of conductive solder that's lying around the place. So we need now to, what do we need to do? We need to connect this to the minus 12 volt just to see which way up is it. So it's the big connector. I've got this upside down. Yeah, it doesn't matter. Right, so yeah, so that's plus 12 volt. The ground is, yeah, between the keyway. So if we put you can't see that. How am I going to do this if you can't see it? Let's spin it round. Spin it round, spin it round, spin it round. You can see the lights, you can see the connector. Okay, now I've got to put this heat sink somewhere where it's not going to melt anything or set fire to paper. Let's use another crocodile clip. I better not. Tell you what I'll do, I'll use the helping hands again. I'll put it down here and I'll get the helping hands to hold it still. That's it. So the helping hands has got hold of it. I'm going to connect the negative up to the rail, to the supply here. One of these will do it. And we know they're both ground, yeah. Okay, and I need to measure at the same time, so let's get the meter back on. Right, we seem to have a lot of mess going on here now. Let's get that out of the way. Right, we've got the meter back. I need to stick crocodile clip on the meter instead of a probe. Right, so get all command up. So we're okay. Command, that's ground again according to that, so that'll do. All that's ground, so no arm done. Right, mains back on. Plug the mains back in. We're on. I haven't switched it on yet though. Right now, we've got our. You can't see that, can you? Let's see if I can get it out so you can see it. Let's get this over here. See if it goes up in smoke. There it is. Just about to see it there. Let's twist it. Right, what we got? Yeah, I think just about to see that there. Helping hands has got it, and I'm going to what I'll be doing is switching it on. I'll just touch it on there, but we need to measure as well at the same time. So what I need is a change that out for a crock with a probe with a clip on it. Okay, I'm changing my meter probe out for one that's got a crocodile clip on it. One of these beauties. So I'm going to hook that onto there. All this will do is let me, that'll let me have the freedom to pulse that onto there. Take it off if it starts going a bit crazy. Just pulse it on. So all I've got to do is switch it on now. I've got my voltage on the go here. Okay. Ideally I'd have a thermometer on there. Measure the temperature, but it ain't going to be on for too long. A couple of seconds if that. And I can hear the transformer power up. Labour a bit if it's too much. This is all very non-scientific. I used to work with this guy, and he couldn't build a circuit for anything, but he could tell you how many watts it was drawing, and before you'd even powered it up. That was brilliant. He used to wear a scientist's white cape. He'd sit there with a calculator, and he'd tell you exactly your characteristics and everything. But practicality, I don't think you could do much. But it was all mental for him, mental work. That's where it counts, really. It's a bit like playing a musical instrument. A lot of people play them, and not many people read. Well, they can't read sheet music. A lot of even successful musicians and singers, they can't read sheet music. But that doesn't stop them. And same thing with me. Didn't stop me. I can work out stuff if I want to, but it take me a lot longer. Anyway, we're going to give this a go now. Let's see what it does. So I've got my meter down here. I could use the top meter, but that's off. So it's this one here, not that one. Right. I'm not gonna switch it on with it on. Switch it on without it, and I'm gonna touch it. So here we go, switching it on. I seem to have no power. Yeah, I seem to have lost power now. LEDs. So now 2 of the LEDs are off. Just gonna switch that off. I must have shorted something out earlier. So while I've got 2 LEDs off, let's find out which ones they are. 36 and 24 volt. So if it wasn't broke before, it's definitely broke now. Unless it did blow a fuse. Let's just check this fuse. Right, looks okay. Looks good. There's another fuse. Alright, anyway, switch it back on. So we've definitely blown some of that last time. And I've still got my -3 volts here, so I can still do the test I wanted to do. So I'm going to touch this on now and see what happens. Try and do it with one I can watch at the same time. Alright, here we go. Yeah, it just drops. It's just gone down to nothing. Yeah, so that you can see that's gone to 0 volts there. So I'll put a load on it, and it's cool. So the slightest load has took it down. Switch it off. Let it die off a bit and switch it back on. Yeah, so we've lost it now. That's interesting, isn't it? It seems to be getting worse and worse. Right, so blown up, shorted those two out. What would that do? That wouldn't necessarily blow the component up. Shorten the legs out. So potentially the voltage was shorted across it. There's no potential difference, so that should have just been okay. Let's try again. Oh yeah, it's definitely gone all together. Well, that's a good thing, isn't it? We had a silly floating minus 3 volts earlier. Right, let's measure some. Take that one out a minute and see if we can measure back again. I want to measure those AC again. So we're on our ground, so this should be 18 volts AC. Is that 18 volts AC? Yeah. This should be 41 volts. Yeah, this should be 41 volts. These are ground. Oh, minus 24 volts. Ah. Minus 24 volt DC. That's weird, isn't it? How can that be DC? We're getting some strange goings on here. Minus 20 volts going down. I don't think it's a good idea to measure this without load on. Anyway, I'm struggling on this. So I thought that. Let me just have a look at that connector. There it is. Like that. Oh, I thought those two were together. They're not. Goes to the fuse. Let's try it again. So that's giving me minus 26. This one's giving me minus 25. Minus, oh they are joined together, but that's giving me minus signal. Okay. That's plus signal. That's a plus signal. It's plus 36 volts, yeah. This one is 18 volts, yeah. That should be ground. That should be ground. This one should be 18 volts. Yeah. So we've got our AC volts. Now we've lost our... We've definitely lost our 36 volts. We've lost our minus 12, our 24 and our 36. We've got our 12 volts and we've got our 5.2. And we've got our sink. Okay. So we are in desperate dire straits now because I've got no spares. I'm pretty sure I've got no spares. Right. Okay, just turn that off. Unplug it. Should we turn it off? So tired. Never mind. Right, so what am I going to do now? That's how I think. What if we just order all the bits? Order some of the bits and I'll look at our drawing again. Is there 24 volts? Let's do some more tests. Let's just make sure we've got our voltage that we had to start with. This is going to be easy to do because we're already set up. Okay. So according to the drawing, the coil near this should give us our 12 volts. Yeah, 12 volts, okay. The next one should give us 24 volts. .1 volts we got. What we got on the other side of it? 2.1 volts, so we're not doing too good there. So we've actually blown it up. Oh, I've blown it up again. I'm deadly with this probe. I'm doing well now. I'm doing well here. Oh, I got nothing now. What have I blown up now? Shit. Dear me. Hang on, let's try again. Oh, we've got 12 volts there. Nothing down here. Down here, what we got? 7 point something volts. And that is the 5 volt inductor. Okay. See, I've actually touched the chip there. That's why you Fluke have an insulated tip, but you can't get near anything with it. 2.1 volts. Why does it keep going off? That's weird. So we need to buy a load of chips. Is it going to be worth it? Why can't you just buy one of these boards? They don't make them, or they only make them in batches. Or we just buy some chips and change them all. See what happens. Right, let's just let's just have a look. I got 41 volts there. 5 point something volts in the middle. Okay, I've done it again. I've done it again. You take your eye off to look at the meter, and then the probe slips and shorts everything out. Oh my god. Still got it. Oh, I've done it again. I'm going cracking up in my old age, surely. Why do I keep shorting it out? Something wrong with my eyes. There's not enough light, is there? I'm trying to do it left-handed because the meter's this side. I'm trying to. I'm just going to blow it up, aren't I? Just going to keep blowing it up. 40 volts. What's the tab say? 5 point something volts. 41 volts there. 40 volts there. 5 point something volts there. Let's just find the 5 volt output. Where is it? Those two, second in here. Before the keyway. That's supposed to be 5 volts. So I've still got my 5 volts. So it's quite robust. Not 5 volts. There's a sincere lack of fuses on this thing. Right, so next, so I've lost me 36 volts. I've lost my, I forgot what I lost now. Lost the minus 12 altogether. I've lost the 24 volt and the 36. And 12 volt inductor is this one up by the connector. So this should be 12 volt down here. Which is 12 volt. So I've got 12 volt there. And this one over here should be 7.7. This one down here should be, that should be 20 odd volts there. So I'm missing something. 25 volts there. 25 volts there. So we've got 18 volts. 25 volts. 18 volts. We've got 4 volts. 2 volts, 3 volts, 2 volts. So this one, we're down on this one. Let's find out what that is. So that's Q1. So look what Q1 is. It's an F9540N. Let's have a look at what that is. Should already know what it is. I found it before, but I didn't write it down. F9540N. Okay, a power MOSFET. That's a power MOSFET. Let's see what it needs on the input side of it. Switching test circuit. Right, I show you a lot of information, but nothing practical. Right, so you got the gate, source, and the drain. So the gate is the power coming in. No, that's the gate. Is the switch to switch the source to the drain, is it? So first pin is the gate, the drain, the middle, and the source. So the gate, I should be able to measure a frequency on the gate. Should be able to. So we've got a gate. Right, so hang on. The source is this one. 3.7 volts on the source. That's not right, is it? I've got an overload on that. Oh, that's the gate. It's being pulsed. Yeah, so that's the drain. Okay, so the drain's 2.1. The source is 3.9, so that's down. That source should be up. So it blown something on the source. And that goes to where? Let me have a look, see if I wrote this one down. Q1 goes to 24 volt middle here. The middle pin here, which is this tab, and that one, goes all the way to this one here. Yeah, and that's to the inductor. And you're getting a weird switching. So if I've put the scope on then. Right, where's my scope gone? I lost it. Here it is. So if I stick the... get another negative. Where's another ground? There's ground, isn't it? Yeah. Let's get another ground off the scope. And measure. Hang on, it's pulling it off. Where can I get a ground from? There's another ground there. Oh, all covered in wires, hang on. Alright, we've got a... Right, so if I touch this onto the one here, I'll have to do an auto there. Hopefully it'll pick up. Let's do another auto. What we got? Nothing. I guess that's something. 50 kilo. 183. Why haven't we got nothing? This should have something. So look at the sink again. This one is the sink. So we've got 100 hertz. Okay, so we've got 100 hertz. How many volts peak to peak? So go on to there. We've got nothing. So we've got a knackered IC there. Let's try another Q. We've got Q3. Q3 is further up, third from the end here, so let's try this one. At 550 hertz. Q1, like try Q2. Q2 is a 12 volts, so we know 12 volts is working. It's 1, 2, 3, 4, 5 ICs. 1, 2, 3, 4, 5 ICs. Right, 111 hertz. Ah, it's varying it. I suppose it will vary it if you think about it. It's got to change it, the switching. It's got to change the switching to match the voltage. So power MOSFET. Might even have some of them. So we've got no power on the one. Lost the power to it. So we've got what's this? How can that be on show? Reconnection successful. What's that doing? So it's reconnected me. Yeah, so we've managed to blow it up a bit more, but at least we're learning as well. We're learning a bit. We're learning. So we've got 4 volts coming there, 3 volts there. So I think the switching's working, it's just the incomer's no good. Yeah. 3 volts. Have we blown this up? We've got 41 volts. 39. 5 point summit. 5 point summit. Is that the 5 volt? One near the connector. Ah, we've blown it up, haven't we? Blown that up. 4 points. We've got 41 volts coming in. 40 volts coming in. I think that's a diode anyway. Is it AC? DC. 7 volts. So that's got to feed this. And it comes out of there. And it feeds this one. Which then feeds out. Let's have a look at that device there near the connector. DP1. So that's a BYV 89E. Alright, let's try it again. BYV 81E. Can't be none of them. It's not coming up with that. 82E. 82E. No. Doesn't like that. What is 89E? 89E. No. Doesn't like it. I can't tell what it is either. Let's try and find out exactly what it is. Stick on the microscope. Let's undo the microscope. Alright, let's try and find out what it is. Let's go on to this view here. What we got? BYV. I can't see it. Can't see that. not showing me, is it? Let's try to clean it. Clean it a bit. Let's clean it up, because I can't see what it says. What's the trouble with this stuff? No schematic diagram. Let's turn it off. Let's clean them all up, why not? That'll do. Okay. Let's go back to the microscope. See if we can see it now. Alright, what we got? Oh yeah, I can't hold it still. Oh. Let's give it some brightness. That's not brightness. That's brightness. Alright, BYV 12E 42E. BYV 42E. BYV 42E we got. So it's a BYV 42E. Okay, let's try and find that. BYV 42E. Here we go. Okay. So we've got a glass passivated high efficiency rugged dual rectifier diodes in a plastic envelope. Oh yeah. Low forward voltage drop, ultra fast recovery times. Okay. So what we got? Diode. Where's the drawing? Shows you in the package. That's a crap data sheet. Pin 1's an anode, cathode. Pin 3's anode 2, and the cathode. Middle pin's cathode. Anode 1, anode A. Anode 1, anode 2. Right, okay. So basically, anodes coming in. They're coming in on A1, A2, or anode 1, anode. Pin 1, pin 3, it's coming in on. And it should be going out on K, should it? Yeah, rectified on K. So it should be getting AC either side of it. What's happened now? I'm on the wrong view, and hang on. Right. Let's turn the microscope off. Microscope. Okay, so let's seems to have gone dark anyway. Right, so we're back on the voltage, so we're going to measure this side here. What we got? Nothing, because I turned it off. Turn it back on again. Right, we've got 42 volts coming in on anode 2, pin 3, 39 volts coming in on, so the pin 3 middle pin should be, it's not, as it's knackered, 8 volts, that should be, yeah, that should be, that's not working then. All that is a diode, an unswitched diode. So there should be plenty of them around. Let's go to the next one. So that is DP1. DP2 is one next to it. There should be the exact same thing next to it, I think. 18 volts there, 18 volts there, and 25 volts, yeah. Yeah. So that's gone. Definitely gone, that one there. Let's find the next one. DP, this one here. Nothing coming in on there. Nothing coming in on there. And where's that go to? Am I looking at the right way around? Yeah. Oh, that joins with that one. 2 point there. Oh. That's weird. Yeah, let's go on there. Nothing on there. Oh. How to switching one. Yeah, so it is there. Okay, so these aren't doing anything because they're not getting enough volts coming in, and they're supposed to be diodes. Let's just make sure. Let's make sure. Switch on the microscope. Swap over. Let's just make sure we are definitely looking at the right stuff. So DP Q what? DP, that one there, what is it supposed to be? BYQ2AD. And that one, is that? Oh no, it's these two, isn't it? That one there. So that's a different device than that. Yeah, I think I'm just going to have to order a load of bits. Order a load of bits, I think. Well, they're different packages. Right. BYQ28E. Yeah, they're both middle bits are joined. Right, I'm going to call it a day. I'll try and find some of those packages. Okay, that'll do for now. Thank you for watching. This is the Maygay Mark 1 PSU Epoch. Trying to fix it. I've actually blown it up and made it worse. But I'm not bothered because at least we're learning. Yeah, at least we're doing a bit of learning at the same time. Okay, well, I'm gone. Thank you. Goodbye.